So that's why we know we're using that like that. It's pretty good. This one here. Okay. All right. I realized I should have given you guys a quiz on Thursday, and I forgot to give you a quiz. So, get a sheet of paper out. And not only will you have a quiz today, but you'll also have a quiz on Thursday. And here's what you're going to be quizzed about. It's just one question here. Or two questions, how about that? Question number one, what is your major / goal? What do you intend to get out of college and your education here? Number two, what is a question you had when you were a kid and has never really been answered? Kind of one of those things that you're always wondering, how does this work, I always wondered, why does the moon float up in the air like that, I always wondered that. Why does the sun float up in the air like that? What are stars, Stuff like that. I know every human being questions their surroundings and questions reality. So I'm interested in what questions did you guys have whenever you were little kids that never really got addressed? That's what I want to know. And because I neglected to give you a real quiz on Thursday, and because I'm going to be giving you a real quiz, this is kind of like a play around quiz. It's not about trig. On Thursday, you will have a quiz about trig, but this is about something that's very important as well. So I want to know what you want to get out of your college education. What's your major and what's your goal? And what's the question you had ever since you were a kid? Write those out pretty quickly. Put your name on it. As long as you answered both questions, you're going to get 100 on your first trig quiz. Okay? Yeah, something to celebrate, right? On Thursday, we will have a legitimate quiz about math where you have to solve problems and you'll be graded off of that. But because I forgot to give you the quiz on Thursday, and because I need to have a quiz, I thought this was a good way to go about it. Also, once you're done with that, come up here and turn in your homework at the same time. That'd be cool. All right. Okay, there we go. Shouldn't take you that long. But I'm very interested in a question that you had ever since you were a little kid and what you intend to get out of your education. chances are, if human beings know the answer to this question, I may be able to explain it to you. If I can't explain it to you, well, then that's just as interesting. There we go. Thank you. Homework and quiz. Yeah, just, I guess put them separate. I like that. There we go. That way I have a list of quizzes and a list of homeworks. Oh. Now, Mr. Pettigrew, am I pronouncing that correct? Yeah. Do you mind if I share your question with the class? Okay, so while everybody else is finishing up their quiz, Mr. Pettigrew wondered, and do you still wonder this question? Or was it just like, I just thought about it when I was a kid, but I never got it answered right? Yeah. Okay. Do you still wonder about this question?
Sure, I guess.
Okay. His question to the world was, do we have an unlimited supply of water? Do you mean drinking water or just mean water in general?
I guess it's water.
Water in general. Cool thing is, you know, water H2O. We can synthesize water in a chemistry lab or in a garage, anywhere you want. All you need is some oxygen gas and some hydrogen gas. And what you can do is form covalent bonds between them. So, a matter of fact, hydrogen-powered fuel cells do that. They take hydrogen gas and they combust it, and its product output is H2O. So hydrogen fuel cells actually produce water as a byproduct, as opposed to nasty smoke and smog. Isn't that cool? It's like a clean fuel cell. I wonder why we're not using more of that stuff. It's kind of weird. Okay. Who's this last? This is the last. Okay, Mr. Ruckman. Yours was just the first quiz on top. Do you mind if I share the question you had ever since you were a little kid? Okay. How many stars can the human eye see? You still wonder this question, or was this a question you had when you were a kid and then you moved on? Right? I mean, that's what typically happens with human beings. They wonder, and if they don't get an answer, they'll have two options: either continue to wonder and try and go pursue it, or, you know, just kind of drop it. There's like this cool action figure over here. I might as well play with that. I can't figure out how many stars can the eye see. Okay, that's cool. All right, I'm gonna look at these, and maybe at the beginning of class, maybe talk about one of them. We already talked about water here. We'll talk about how many the eye can see later. All right. So we're going to talk about section 1.5 here. What is the sine, cosine, and tangent of this right triangle? Sine of theta is the opposite over the hypotenuse. Okay, opposite meaning where your angle is, theta, pick the opposite leg to it. So opposite of that is this y, okay, divided by the hypotenuse we indicated as r. Now let's do cosine of theta. Cosine is the adjacent divided by the hypotenuse. Okay. to this angle theta, the leg that is adjacent to it is x. I know you're thinking, well, isn't r also adjacent to it? The answer is yes. R is also adjacent to it, but r is the hypotenuse. So when we say adjacent, we mean the leg that is adjacent to it that is not the hypotenuse, which is x. Over hypotenuse r. And what is the tangent of theta? Toa. Toa. Right? The SOHCAHTOA, you guys know SOHCAHTOA? Yeah. So it's opposite over adjacent. And for the young lady that came in a little late, you missed a quiz, but it's not a hard quiz. Question number 1 on the quiz is your major. Question number 2 is a question you had since you were a kid. Meaning, like, write down a question you always had ever since you were a little kid, but never got answered. Okay. Yeah, I was always wondering this, but I never got it really answered. That kind of stuff. Turn it in, and if you fill out both of those, you should get 100. But on Thursday, next class period, we'll have a real trig quiz. Okay. This is the freebie. Now, this is how we define sine, cosine, and tangent. And I promised you all I would prove to you why you cannot divide by 0. Notice that the denominator can't equal 0. But this is a question that you never had answered ever since you were a little kid. They just told you don't divide by 0, right? You can't. Did you ever ask why? Whether you asked out loud why or internally why, that doesn't matter. I know for sure everyone asked why. Is there anyone here who didn't ask why? Even though I think I'm pretty certain. Everyone did ask why. Okay, here's why you can't divide by 0. All right. Give me a number, somebody. 5. Say we could divide by 0. Let's say 5 divided by 0. What would it equal?
0.
Okay, let's say it equals 0. I will show you that this assumption is going to lead to logical contradictions in mathematics. Notice that if I multiply both sides times 0, okay, the zeros cancel over here, so I get 5 is equal to 0 times 0, right? But 0 times itself is what? So you're telling me 5 is equal to 0? Is 5 equal to 0? No. No, it is not. Contradiction. You broke math. You destroyed mathematics. Because you get a result, 5 is equal to 0. That's not true, right? So you destroyed math. Math is supposed to be logical and consistent. 5 should equal 5 and 5 only. Can't equal 0. That's one thing, but I know what you're thinking. Okay, yeah, but what's 3 over 3?
1.
What's 17 over 17? What's x over x? So anything divided by itself should be 1, right? You know what? Maybe this. You know what, Professor Niazi? How about this? I bet you that's true. I thought that before. I wondered, can you divide by 0? And why? Teachers told me to pipe down. Stop asking so many questions. That made me really angry. Teachers aren't supposed to say that. Teachers are either A, supposed to explain it to you, or B, admit they don't understand it and give you the resources to help you understand it if they themselves don't understand it. Am I wrong? Duh. Yeah, no, I'm not wrong, right? Okay, so even this messes up, and I'll show you why. Let's algebraically multiply both sides by 0. Okay. Notice they cancel here. Let me create some space. They cancel here, so I get 0 because they canceled here. I just get 0 is equal to 1 times 0, right? Oh, but 1 times 0 is 0, right? Yeah. So this works. This works. What are you talking about? What are you talking about? We found something where we can divide by 0. Everyone go home. Nope. Actually, there's more to it. Okay? What if I were to add to both sides another 0? Adding 0 doesn't change anything, does it? So we still have this equation. So now I get 0 plus 0, which is what? Okay. Over here, I'm going to do something called factoring. You guys remember what factoring is, right? But I'm going to factor out a 0. When I factor out a 0 from here, I get 1. When I factor out a 0 from here, notice I can get n, where n is any number, right? Because whenever I put this 0 back in, 0 times 1, 0, plus 0 times any number is, and 0 plus 0 is, so I would still hold this consistent equation, right? But then let's divide both sides by 0, okay? Meaning the zeros here cancel. So now I have 1 plus n is equal to 0 over 0, which we assumed is equal to 1, didn't we? Notice that n can be any number. What if I pick n to be 5? I heard you. That means I get 1 plus 5, which is 6, is equal to 1. Is this true? No. No, it's not. You break mathematics when you do that. So it's inconsistent logically to say 6 is equal to 1. Contradiction. That's why you can't divide by 0. It's as simple as that. You had the capacity to understand it. It only used all the ideas we use every day, divide both sides by something, cancel stuff out. Why couldn't you just get a little quick excerpt about this? I fulfilled my promise. And now you know why the denominators here can't equal 0. Because mathematics is no longer logically consistent when we divide by 0. So we must make these numbers non-zero if we wish to ever aspire to calculate these ratios. Okay? And once you're done with your quiz, also turn in your homework. You don't have to do that right now. You can do it at the end of class. It's up to you. Okay, back to sine, cosine, and tangent. All right. What is 1 over sine? It's a definition, right? Just like sine is opposite over hypotenuse, which is on this triangle, that 1 over sine is defined to be something. Who could tell me what that is? Yes, sir. Cosecant of theta. But notice, how can I represent cosecant of theta with x, y, and r? Notice the key is here. If sine of theta is equal to y over r, and the reciprocal of sine is equal to cosecant, this needs a c here, cosecant. Notice that effectively to find what cosecant is, I just need to take the reciprocal of this, 1 over y over r. And multiplying by reciprocals, I had, this is a y, r over y. So this cancels out to become 1. So what does cosecant equal?
R1.
Yeah. You don't got to do that each time, though. Just flip them. So what is secant equal to? That's right. That's equal to 1 over cosine of theta. So what we do, we find cosine, it's x over r, flip it. So what do we get when we flip it?
X over what? Or which one?
Cosine?
Oh, R over X.
Yes. Make the sound effect. You can do it in your head, or you can do it out loud. Yeah. Ever since I was a little kid, I would have like shapes in my head, and I would make them rotate to sound effects. I've never outgrew it. Still make sound effects when I rotate things in my head. Yeah, so. Now, what is 1 over tangent? Cotangent of theta. So, given that tangent is y over x, what should cotangent be?
X over Y.
There we go. Well done, class. See, I like to mix in some new stuff with the stuff that you guys have most likely seen before. Chances are a lot of you have seen sine, cosine, tangent before. And if not, that's fine. I think I called this 1.5, but I think it's 1.4. Does anybody have their book on them?
Yeah.
Yeah, could you take a look at what 1.4 reads, the section title? I think I called it 1.5, but I would believe this is 1.4. It's not a big deal. We're going to be learning 1.5 as well. What is the title for 1.4?
Fundamental identities and families of identities.
Oh. Where is that in my notes here? Why am I skipping a section? I don't know where I put that.
I don't actually believe there's a 1.5.
Oh, it's not even a 1.5.
Because after 1.4, there's like the summary and concept.
Right, yeah.
And then starts at chapter 1.
Okay. Yeah. No, yeah. I just wrote 1.5, and it should say 1.4. Okay. Oh, here it is. I see. Problem solved. I found my notes. Whew. I need to sleep more. Okay, so we're at 1.4, guys. And this is identities, trigonometric identities. All right. Now that we've talked about sine, cosine, tangent, secant, cosecant, cotangent, let's talk about the Pythagorean identity. Who knows what sine squared theta plus cosine squared theta is equal to? For any theta, sine squared theta plus cosine squared theta. Who knows what this equals?
1.
Oh! How did you know that?
I remember helping a friend of mine with this.
You just remember. You think I'm going to be cool with that?
No.
I'm impressed that you know it. But I want to prove that this is true. Okay? We are going to prove that this is true. Here's a proof. And really, the proof is not that bad. All it uses is sine, cosine, and tangent. Or not tangent, just sine and cosine here. Notice that sine of theta, as we've highlighted here, is y over r. Notice that cosine of theta, as we've highlighted here, is x over r. So sine of theta plus cosine of theta is that stuff squared. It's y over r quantity squared plus x over r quantity squared. Okay. I'm not going to assume it equals 1. I'm going to show it equals 1. Okay. I'm going to start off with sine squared plus cosine squared, which is this. And I'm going to do steps that hopefully result in it equaling 1. If I'm a mathematician that is worth my weight in gold, I should be able to do it. Notice that the squares distribute to the numerator and the denominator. Right? You guys remember that that happens? Yeah. Okay. Notice that we could combine them under that common denominator here, right? Right? Okay. Here's the rub. You remember what r equaled?
That's the hypotenuse?
It's the hypotenuse. R is the hypotenuse. So do you remember what r equals?
Oh, square root of x squared plus y squared.
Very good. You achieved that because you just used the Pythagorean theorem, right? Took the square root of both sides to just get that, right? Pythagorean theorem, r squared is equal to x squared plus y squared. Take the square root of both sides, so I just get r is equal to square root of x squared plus y squared. Now, we don't have an r to deal with. We have an r squared to deal with. So what happens when I square this quantity? I get r squared is equal to what? Pardon me?
Wouldn't it just go back to being like r squared equals x squared plus y squared?
Yes. Because whenever you square a square root, that radical goes away, right? That square root, when you square it, the radical goes away, okay? So we get r squared is equal to this. Notice what happens when I replace r squared with that.
Oh, because it equals.
What does this equal?
1.
1, yes. Why does that equal 1? What's 2 plus 3?
5.
What's 3 plus 2?
5.
Oh, so it doesn't matter what order I add stuff in, right? Here the y came first, then the x. But here the x comes first, then the y. It doesn't matter. Yeah, it doesn't matter, you know. The 2 plus 3 is 5. 3 plus 2 is 5. In our simple-minded mathematics, that is. As I told you before, when we get near the very intense gravitational pull of a black hole, mathematics as we know it breaks down. Just like how when we divide by 0, mathematics breaks down. All the mathematics that human beings have invented breaks down at that point. That's why I wear these ties, so I can bring up black holes. Who here knows what a black hole is? You mean you don't incessantly talk about black holes with your friends? What do you guys talk about? TikTok? What are you young kids about these days? Snapgram? Is Snapgram a thing?
Snapchat.
You mean Insta Snap?
Yeah.
I'm only 29. I know what they are. I just like to act like I don't because it's really annoying. All that social media stuff is really annoying. But anyways, yeah. I can describe what a black hole is to you. If you want. Really, a black hole is a region of space that has infinite mass density. You see, density, D, is equal to the ratio of mass divided by volume. But when you get a finite volume and you stuff a lot of mass in there, it turns into a black hole. So let me give you a conceptual understanding of that. If we stuffed the whole planet Earth into a sugar cube, then it would turn into a black hole. The whole planet Earth into a sugar cube. If someone had the ability to do that, crush the Earth into a sugar cube, it would turn into a black hole. What is a black hole? It's a region of space that nothing can escape. Once you're there, you fall into the black hole, and you fall in there forever. For all we know, there's no way for you to come back, because not even light can escape a black hole. And light is the fastest moving thing we know about. Light can go around the Earth 7 times every second. A little more than 7 times. The whole equator of the Earth. Yeah, she's like, whoa, dude. Yeah, it's really cool. We live in an amazing universe. So thus we have proven the Pythagorean identity. You don't have to prove it. You could just use it, okay? Now let's prove another Pythagorean identity. Tangent squared theta plus 1 is equal to secant squared theta. How do we go about proving this? Well, my suggestion to you is start with one side of the equation, then work towards the other. Prove. And usually I will give you excessive information, like, oh, this is why you can't divide by 0. But actually, right now, these proofs are actually part of your curriculum. So you'll have to prove stuff on your homework. You'll have to prove stuff on your quizzes. You will have to prove stuff on your tests. Okay? So this is not extra stuff. Why are you taking so much time proving? Sometimes I will take extra time showing extra information because I want to make you guys learn more about math. Okay? Give you access to more information that you never had. But right now, this is actually stuff you need to know how to do, okay? So my suggestion to you is start out with the more complicated looking side, because we have been well trained in simplification. Start out complicated and simplify, okay? Now, who can tell me what tangent is equal to?
Sine over cosine.
Aha! Tangent is sine over cosine. But wait a second. Wait a second. Here's x, here's y, here's theta, here's r. Didn't we say tangent of theta is equal to y over x? We never said it equals sine over cosine. We said it just equals y over x.
But we also said that sine equals y and then cosine equals x.
Kind of. If your hypotenuse is equal to 1, then you are correct, right?
Yeah.
But if your hypotenuse is not equal to 1, you're not necessarily correct. Right? When r is equal to 1, sine is equal to y, and cosine is equal to x. But in general, it's not always true. Your hypotenuse has to be equal to 1. And in trig, usually is because you're working on the unit circle. We're not talking about the unit circle yet. But that's why you could get away with saying that sine is y and cosine is x, is because you are always dividing by 1. But here in general, it's not true. Really, we see it's sine over cosine because let's divide sine over cosine here. Y over r divided by x over r. Notice that when we multiply by reciprocals, I get r over x times r over x. This cancels to give me 1. The r's here cancel. So I get y over x. And that's why. Because this was sine, remember? And this was cosine, remember? So now, we can just always say tangent is sine over cosine. Because we've proven it. We understand it. I emphasize understanding over memorization. And here's why. Memorization is really... Who here tried to remember something in a really stressful situation? It's hard, right? It's hard to recall memories in a stressful situation like a test. But if you understand what's going on, you can like wiggle your way to the answer, if you will. So understanding is a superior method of studying, because that way you have to memorize less. Okay. So back to proving this guy right here. Tangent squared theta then. Tangent squared theta plus 1 equals sine squared theta over cosine squared theta. Does it not? Does it not? It does, right? Yeah. Because we distribute the square to the numerator and the denominator right here. And we got to add that 1 because this is what we're trying to prove. Notice that to establish a common denominator, we have to multiply this 1 top and bottom by what? I have to multiply this 1 top and bottom by what?
Cosine squared over sine squared.
Close. If I did that, then it wouldn't reduce to a fancy number 1, right? Because like cosine squared theta over sine squared theta does not necessarily equal 1, right? We want to multiply it times a fancy number 1. So, okay, what's 3? What's 2/3 plus a 1/4? How did you do that? Remember?
We need to come up with a common denominator.
Common denominator. So I multiply top and bottom here by what?
4.
4 times 2 over 4 times 3 plus, I multiply top and bottom here by what?
3.
A 3. So I get 1 times 3 over 4 times 3. This is really nice because that becomes 8 plus 3. And they're both 4 times 3 under the denominator. So we can put them under a common denominator, 12. So over here, I have plus 1, and I want to multiply it times a fancy number 1. So what's on top needs to be the same as what's on the bottom. And if I want them to both have cosine squared theta as the common denominator, then I'm going to use cosine squared theta over feel free to say it if you want. Cosine squared theta over itself, because that's the only time it becomes 1, right? Anything divided by itself is 1, except 0, as we've discovered together, right? We always have to say except 0. Okay, so now moving the calculation up here, I get sine squared theta plus cosine squared theta all over the common denominator, cosine squared theta. Right? Right?
So we made the 1 cosine squared theta over cosine squared theta.
Precisely. Yes, ma'am. And then combine them under the same denominator. Okay? Is everybody following? Is there anything that not following? Okay. Notice what happens to the numerator if we apply this equation. What does the numerator reduce to? The numerator is sine squared plus cosine squared theta. What does this equation say that that is also the same thing as? Yes! Are you guys just shy today? You guys just tired? You guys been up too late on tic-tac? Tic-tac paddywhack? I was up late too, but I was not on tic-tac. We got this equals 1 over cosine squared theta, right? What is that the same thing as?
Secant.
Yes, ma'am. And so it's secant squared theta, so done. We're done with the proof. Feel free to write QED at the end of your proof, or put a box. This is typical amongst mathematicians to do that. Who can tell me what that QED stands for in Latin? It doesn't stand for quantum electrodynamics. It stands for quod erat demonstratum, which means thus it has been proven, or thus it has been demonstrated, or thus it has been shown. And for you guys who are scrambling to write it down, these videos are on Canvas. You guys can access it. So if I ever erase something you didn't write down, you could just rewatch the videos. So that's actually a blessing. That silver lining to this whole fiasco we're all in right now. That's why we're all wearing these masks, right? That's a silver lining to all that stuff. That you guys get to rewatch lectures. Some of my colleagues, when I was an undergrad, would bring recorders to record the lectures. And nobody really could videotape it back then. So it's just kind of a blessing that we get to rewatch the lectures. That's really cool. Let's do another Pythagorean identity. 1 plus cotangent squared theta is equal to, yes, sir. Yes, sir. How did you know that?
Well, I just remembered.
Did you remember it? Well, we're about to prove it. That way, if you ever started out with a 1 plus cotangent theta squared, you could actually derive that it equals cosecant squared theta. That's what I want you guys to do. I want you guys to be like, memorization? Nah. I could just derive stuff in my head. Of course, a little bit of memorization is okay. And of course, I think I'm all right with giving you guys like a note card for tests where you can write these identities down so you don't have to memorize them. And you don't have to rederive them either. Because that does take some time and that does take some energy, right? You don't want to over and over do it again while ignoring the problem that you're supposed to solve. So I'm on your team. I'm on your side. I want all of you to be successful. I want to give you all the tools necessary to make you successful. I'm throwing the ball in your court. After that, you guys got to work hard. And I know every single one of you is highly capable of doing that. Now, right here, 1 plus cotangent squared theta. I suggest you always prove this. I suggest you always start with the more complicated side. What is cotangent squared theta? The same thing as
1 over tangent.
1 over tangent. Okay.
Or it's also like,
X over
yeah, x over y.
Right. So let's think about it like this. What was tangent of theta? Okay. And so 1 over tangent theta, which is cotangent theta, will be 1 over sine theta, or cosine of theta. And 1 over 1 over here, so when I multiply by reciprocals, cancel. I get cotangent is cosine of theta over sine theta.
Oh,
Yeah. So this stuff is true, it's not wrong, but really 1 plus cotangent squared theta is the same thing as cosine squared theta over sine squared theta. Because if this is cotangent, then squaring this gets the square to the numerator and the denominator. Making sense? Good. And if not, We will work on it. Send me emails with your questions or and whatnot. I should have brought my box of chalks. I'm just gonna have to make do with these chalks here. Okay, so notice we get this. We have to establish a common denominator. I multiply top and bottom here by what? A fancy number 1, right?
Sine.
Sine what?
Sine squared theta
Over what?
over sine squared theta.
Excellent. Excellent. Notice that we're multiplying by 1. 1 doesn't change anything. And that's why we could say that this side equals that side. Because we didn't change anything. This side equals that side because when I multiply by a fancy number 1, I didn't really change anything at all. But yet, I changed the way it looks, right? You change the way it looks even though you didn't change what it was. And that's why math is so powerful. We change stuff without changing it. So this becomes sine squared theta plus cosine squared theta all over their common denominator, sine squared theta. Okay, but how can I get that that somehow equals cosecant theta? I'm lost. I need you guys' help. I am stumped. This problem has defeated me and I need reinforcements as help here, which is you guys. Come join me on this mathematical battlefield. How can I result this expression to it being somehow equal to cosecant squared theta? Yes, sir.
Because if you add sine squared plus cosine squared theta, that equals 1. So 1 over sine squared theta is cosecant.
Squared theta. Very good. You not only told us what it equals, you showed us how. I'm very happy with that and very proud. Very proud of all of you right now. Okay, continuing on, we're going to prove some more stuff now. Example here. I'll move this in here. Let's find 2 more identities from, let's say, this equation right here, 1 plus cotangent squared theta is equal to cosecant squared theta. How may we extract more identities? Identities are just relations. Relations are just equations. So we're just aspiring to find more equations. And the way we get more equations is by doing algebraic operations on a starting equation. So one simple way of doing it is taking the square root of both sides. Notice if I take the square root of here, square root of here, I get cosecant, not squared anymore, it's just normal cosecant of theta, is equal to plus or minus the square root of 1 plus cotangent squared theta. And who could tell me why this plus or minus is here? Before you answer that, who could tell me what is the square root of 4?
2.
2. No.
plus or minus 2.
Yes. When you say square root of 4 is 2, you really mean that the principal square root of 4 is 2. The square root of 4 is really plus or minus 2. And here's why. The square root of 4 equals some number. Okay? The square root of 4 equals some number such that when you square both sides, that number squared is equal to 4. Notice that both positive and negative 2 satisfy this. Look. Positive 2 squared, that's 4. Check. -2 squared, that's 4. Check. That's why we say plus or minus, because it is the all-encompassing answer. Isn't that cool? Did you guys know why you said plus or minus before? Isn't that cool? Yeah. Yeah, I saw eyebrow raise, meaning that is cool. And a nod, that means yes, it's cool. And the head bob with the hair flow. Okay? So this is why we were able to extract 2 new identities here. And this, you can write it down or etch it into your memory or rewatch. That's an explanation of why whenever you take a square root, you get plus or minus. That is why. That's the reason why. Just like 4, that applies to this right here. It applies to that expression. That looks more complicated than the number 4, but it still applies to it.
So that's a new identity?
Yes, you get 2 new identities. Yes, sir. You get the cosecant of theta is equal to square root of 1 plus cotangent squared theta, but it also equals negative square root of 1 plus cotangent squared theta. Yep. But I don't want you to like have a note card filled with these guys. You could have just started off with 1 plus cotangent squared theta is equal to cosecant squared theta and just derived these identities. If you needed to derive them. If you don't need to derive them, then why do it, right? Maybe just for fun. But for like a test situation, you know, I don't want you rederiving identities while ignoring the test problems or the quiz problems. So how about this one? Show cosine of theta multiplied times secant of theta minus cosine of theta is equal to sine squared theta. Let's show that this is true. And as always, we will start off with the more complicated side, which is the left-hand side in this case. Cosine of theta times the quantity secant of theta minus cosine of theta. Let's go. There we go. What can we do here? This is the cosine of theta being multiplied times this quantity. So this cosine of theta needs to distribute to both of these terms, right? Yeah. Let's do it. I get cosine of theta times secant of theta minus cosine of theta times, cosine of theta. Next, in this step-by-step process, you want to take anything that is tangent or cotangent or secant or cosecant. We want to express everything in terms of sine or cosine. Okay? Because everything is based off of sine or cosine. Even tangent is based off of sine or cosine. Tangent is sine of theta divided by cosine of theta. So the most essential 2 trigonometric functions are sine and cosine. After that, everything else gets built off of sine and cosine. So even in our identities, we want to reduce anything that's not a sine or a cosine into a sine or a cosine. Which one of these can we do that with? That's right, the secant. What is secant equal to?
1 over cosine theta.
Aha. So I get cosine of theta times 1 over cosine of theta. I replace secant with that. And this cosine of theta times cosine of theta, I just might as well just write cosine squared theta, right? What happens over here?
They cancel.
Yeah. This is really cosine of theta divided by cosine of theta. Anything divided by itself is what?
1.
Yeah. So this ends up becoming 1 minus cosine squared theta. Oh, but that doesn't equal sine squared theta. Let's just quit being mathematicians, guys. This stuff is just too heart-wrenching. We put all of our time and our effort into trying to get this thing to look like sine squared theta, And it turned into 1 minus cosine squared theta. Recall an identity we have proven. We don't give up as mathematicians. We never give up. We don't stop until we figure it out. And then if we don't figure it out, we keep trying until we perish. That's right. You like that mentality, don't you? That's right. Grind till you kick the bucket. So notice that Pythagorean identity can get manipulated somehow to solve for this expression right here. What if I were to take this right here, subtract the cosine squared theta from both sides? I would get sine squared theta. Wait, but that's just right here, right? That's the same thing as here. So if that is the same thing as here, then I have proven that that equals sine squared theta. So all you needed to do to solve this problem was to invoke the Pythagorean identity here and algebraically solve for sine squared theta, realizing that this 1 minus cosine squared theta is secretly a sine squared theta. It's a secret. And the secret you can access if you take the Pythagorean identity and just solve for sine squared theta. Make sense? Okay. It's okay if you're not as fluid with this stuff right now. You will attain more abilities with more practice. Practice really does make perfect. And I believe all human beings are capable of learning anything with enough practice. I think I can even learn to fly. I'm just going to learn how to fly real quick. I just got to practice it and I can learn how to fly. Well, maybe I'm not like, floating flying. Maybe I need to create some type of apparatus to help me do it. Like an aeroplane, or you guys seen those jets, the dude who invented the first jet suit. It's called Take On Gravity. It's really cool. This dude has these like jet suit backpack, and he has two-handed jet suits, and he can just like fly. It's called Take On Gravity. We have jet suits now. We have the technological capacity to like fly around like the Iron Man dude. Costs a lot of money though. I'm sure having that jet suit will be millions of dollars. But it's really cool. I want a jet suit, not gonna lie. So if any of you guys wanna gift me a jet suit, I accept. In advance, I accept that. I would totally like to fly around lakes and stuff like that with that on. Let's prove another thing. What about sine cubed theta plus cosine squared theta times the sine of theta, everything divided by cosine of theta. Let's prove that this equals. And again, let me reiterate. This is not stuff I'm just showing you because I think it's cool and I want you to think it's cool, because it is cool. I don't just think it's cool, it actually is cool. But this stuff is actually in your assignments and in your homework. So don't zone out. That's what I'm trying to say. Don't zone out and think you can get away with it. Oh, I can zone out. This isn't part of my grade. He's talking about black holes and theories of quantum gravity and quantum electrodynamics and how photons in this room are just spin 1 gauge bosons of the electromagnetic field, which means they're the force-carrying particles that influence electrons and positrons, which are spin 1/2 leptons. Yeah, that stuff is not on the test, but it's still cool. But this stuff is on the test, so you can't zone out, all right? Let's prove this thing right here. this expression right here. I advise you not to start off with tangent and try and come up with this stuff. We are well trained in simplifying, right? Simplify, simplify, simplify. You've been told to simplify for a while now, so you're kind of good at it. Okay, so let's start off with the more complicated side and simplify it, if you will. Okay. What can we do here? How can we simplify?
Can we take a sine out
Yes. Where?
from, it would take a sine out from both of them, right?
You mean in the numerator?
Yeah.
Take a sign out from here, take a sign out from here. Factor out a sine of theta. This would reduce to sine squared theta then, plus cosine squared theta, all over a cosine of theta. Now what?
That equals 1. Sine squared theta plus cosine squared theta equals 1. So it's just sine over cosine.
That's right. Hold up, this part. I'm trying to keep up with you. Equals 1. So let me just write down what we have here. So then what happened? What'd you say?
Well, since sine squared theta plus cosine squared theta equals 1,
I did that.
and 1 times sine, 1 times sine theta equals sine theta over cosine theta, that equals tangent theta.
Yes. Well done. Oh, that's what we're trying to prove.
Yeah.
So that's why we're excited now. Time to get this on the gram. Time to get this on the snap top. What is it, snap top?
Snapshot.
Tick chat, talk chat. Facegram. I don't care. Oh my gosh, I don't do not care. Here we go, here we go, here we go, here we go. But I will admit, you know, when you're growing up, peer pressure makes you kind of want to care. Because you know everybody's on there, I want to be cool too. Nah, the real cool people are chilling at home doing math all day. That's the real cool people do. We do math all day and we try and create theories of quantum gravity because then we can somehow invent wormhole technology and then we could travel to distant planets and stars. We can find aliens there. Who here thinks aliens exist? I was just curious. Are y'all one person? No. Nobody else thinks aliens exist. Truth is, we don't know. We really don't know if they exist or not. Maybe ET is out there trying to phone us. Let's do another proof. Cosine of alpha minus sine of beta squared. Prove that this somehow equals 1 minus 2 cosine of alpha sine of beta. Let's start off with this side here. Cosine of alpha minus sine of beta, quantity squared. What does it mean when something is squared? What does x squared even mean?
X times X.
It just means x times x, right? So this whole thing with the parentheses squared just means this whole thing times itself. So let's write that out clearly. This whole thing times its self.
You can distribute after that, right?
Mm-hmm.
There's more chalk over this.
Oh, wow. Thank you. I love it when students help me out. I'm trying to have you guys help me out all day. That was very helpful. I was about to start like writing on with my nail. My nails was getting too close to the board. And now I have some more distance to work with. Now someone said distribute. Cosine of alpha times cosine of alpha is cosine squared alpha. Cosine of alpha times negative sine beta is negative cosine alpha sine beta. Then negative sine beta times cosine of alpha is another negative, and watch. I'll just write sine beta cosine of alpha. And then negative sine beta times negative sine beta is positive sine squared beta. What can we do here? Now, what can we do here?
You can combine, well,
Yeah.
yeah, we can, right? Cosine, or negative cosine of alpha and sine of beta minus.
What
Or
does
it
it do?
doesn't really matter, does it?
No. What's 2 times 3?
6.
What's 3 times 2?
6.
Yes. It doesn't matter. There is mathematical theories out there that do math where it does matter. Where 2 times 3 will not equal 3 times 2. That's a field of mathematics called non-commutative algebras. It's really cool and interesting. But we won't be doing that stuff. I'm just advertising for it. Right now, I'm just advertising for it. So notice that these are the same, the order is different. So it's just 2 of these. Right? And then I'm just gonna write what I got left. Now what? I wanted this. I don't have this.
That equals 1. Cosine squared alpha plus sine squared beta equals 1. Right?
Oh man. I invented this problem, but I invented it wrong. Oh no, I invented this problem the other day. I invented it wrong. This is not even a true statement. And here's why, okay? I lied, yes, but I at least caught myself. You asked cosine squared alpha, but this allows me to teach you something really good, because now you won't fall under this pitfall. Maybe I did it on purpose. Cosine squared alpha plus sine squared beta, does it equal 1? It doesn't. And here's why. The angles aren't necessarily the same. Yeah, cosine squared alpha plus sine squared alpha, that for sure equals 1. But cosine squared alpha plus sine squared beta does not necessarily equal 1, which means that this is not even true. So by prove, I should write prove / disprove. Now it's legitimate, right? But this allows you to answer the question that might arise. Does this cosine squared alpha plus sine squared beta, does that equal 1? The answer is no. They're not the same angle, okay? The Pythagorean identity here is only true if the angles are the same. It's not necessarily true for different angles. There's no better way to learn than to mess up. You can quote me on that. Okay? There's no better way to learn than to make mistakes.
So what would have to change in the problem for it to actually be able to be proved?
Oh, that's a good question. What did I have here? The truth is, I had sine alpha minus, was it sine first or cosine first?
Yeah, cosine first.
I had cosine first? Yeah, that's why this came first, right?
And then negative was sine.
Cosine alpha sine beta, right? This just equals this. This just equals this, and that's it. You can't go any further. You just can't go any further. You got to stop there. That's as much as you get, because they're different angles. I could like create a problem out of it, you know. I could, given this, I could factor out a cosine, and I can get tangents to form. Okay. You want me to elaborate on what I just said, or move on to a different problem?
I guess move on to a different
Okay. Yeah, I could make tangents out of this situation here. Okay. Now, here's another problem. Example. Write sine of theta in terms of cotangent theta. So, what do we mean? What do I mean in terms of? This in terms of stuff just means write sine of theta equal to cotangent stuff. To know what that stuff is, we must deconstruct what cotangent of theta is equal to. What is cotangent of theta equal to?
Cosine for
cosine
sine.
over sine.
Correct. Cotangent of theta is equal to cosine of theta over sine of theta. I want sine of theta to equal cotangent stuff. So really, I can start out with this expression and solve for sine of theta. This expression right here, this whole thing, solve for sine of theta. So to do so, I have to multiply both sides by sine of theta to isolate it. And then I want just sine of theta all on its own. So,
divide by cotangent.
yes. So we found sine of theta in terms of cotangent theta. It just so happens it's also in terms of cosine of theta. But saying so would, I guess, be too much. That's it. When you say find something in terms of that, this is what in terms of means. Sine of theta in terms of cotangent theta means get sine equal to stuff that has cotangent theta in it. Yeah, that's it. See, we have, yeah, this class is over at 9:15, right? All right, we had two more examples to go through to finish off this section, but we'll do that next time. Next class period, we will have a quiz. It'll be a legitimate quiz with trigonometry on it. Although this is a legitimate quiz, and everybody who turned it in will get 100. So be prepared for that.
Do we know like what lessons are just up to now?
Up to now. Stuff that's up to now. Okay. And yeah, turn in your homework. You'll be assigned homework out of this section because we've basically covered all of it. So. I don't feel as bad. If I only got halfway through it, I would give you an extension. But we didn't. We got almost through all of it. Maybe if I didn't talk about black holes as much, we would have gone fully through it. But it's just like one or two more examples.
If we get stuck, we can email.
Absolutely. Feel free to email me. Yes. And the sooner you do it, the better. Because the more time you give me to answer you, the more time I'll have to answer you, the sooner you can get the response. And then that means the sooner you can get unstuck on your homework or whatever. No problem. Have a good day to you too as well. Goodbye.